Metro trains are primarily powered by electricity, typically sourced from overhead lines or third rail systems. Overhead lines supply 25 kV AC, while third rail systems provide 750 V DC. Electric motors, commonly three-phase AC induction motors, convert electrical energy into rotational motion to drive the train's wheels. Regenerative braking allows motors to function as generators during deceleration, feeding electricity back into the grid. Metro trains achieve efficiency by minimizing friction using steel wheels on steel rails. Steel-on-steel contact allows for smooth and energy-efficient movement of metro trains. Computer systems precisely control acceleration and deceleration for a comfortable ride. Accurate stops at stations are achieved through precise computer control of the train's movement. Streamlined train car designs reduce air resistance, especially crucial in underground tunnels. Rails are mounted on sleepers, typically made of concrete or steel, to distribute the train's weight evenly. Communication-based train control, CBTC, systems manage train spacing to prevent collisions and optimize service frequency. CBTC optimizes service frequency by dynamically adjusting train speed and spacing based on real-time conditions. Magnetic track braking systems use electromagnets to create strong friction with the rails for rapid stopping in emergencies. Tunnel boring machines, TBMs, excavate tunnels through soil and rock. Simultaneously, concrete rings line the tunnel walls to withstand external pressure. Ventilation fans and shafts regulate air pressure and ensure fresh air supply. Elevated tracks are built on reinforced concrete pillars to conserve urban space. Modern metro systems employ driverless technology, guided by sensors and monitored from central control rooms. Real-time systems oversee train speed, door operation, and passenger safety. Fire-resistant materials enhance passenger safety in the event of an emergency. Emergency braking systems and comprehensive communication networks further ensure passenger safety. Metro trains are more energy efficient compared to individual cars or buses due to lower energy consumption per passenger. Metro systems reduce reliance on fossil fuels by operating on electricity. Decreased reliance on fossil fuels leads to a reduction in urban air pollution. Metro track designs incorporate damping pads to reduce noise pollution. Sound barriers further reduce noise pollution from metro systems. Electric propulsion powers the metro train system, enabling clean and efficient urban transportation. The physics of steel-on-steel contact minimizes friction, facilitating smooth and energy-efficient train travel. Advanced signaling and automation systems ensure metro train safety and operational reliability. Engineered tunnels and elevated tracks optimize space utilization, contributing to efficient urban transit solutions.